So this is a double pendulum. It has two nice stable modes of operation. So one is where the two bits are in phase, and it swings just more or less like a normal pendulum. And then you can also set it up so they're out of phase, and it oscillates a bit faster, but it's nice and stable. But a double pendulum is chaotic, so if you give it a big initial kick, then it will behave chaotically. When I used to demonstrate this in lectures, I would have the students put their hand down when they thought the bottom one had done its last loop-the-loop. And it's amazing how often you think it's finished and it's settled down, and then it manages to get some energy from somewhere and do another loop.
It's a very simple thing. It consists of a cardboard tube with a membrane at the end of it, a tight membrane, and then this flexible spring at the end. What it does is it takes the mechanical vibrations of the spring and translates them into sound. And it does so remarkably effectively. You don't have to put much energy in to get a very loud noise. This is a problem of huge practical interest, because noise control is absolutely vital in all sorts of things, from aircraft taking off. I once heard that the amount of energy emitted in the form of sound by an airliner taking off is about enough to fry an egg. So airliners taking off, air conditioning systems, traffic, road noise, all of these things, very difficult to control because of the tiny amounts of energy that make a really quite loud noise. There's some lovely work done by my colleague Nigel Peake and his group in Cambridge on how to minimise the noise of air going over a wing, which is something that nature has solved with the flight of the owl, which is soundless and it swoops on its prey.
Hi, I'm James and I've got a fluid mechanical hourglass. It works like this. There's blue and pink fluid at the top, and there's a clear fluid that's being displaced as the heavy liquid falls down to the bottom. But on the way from top to bottom, it does several interesting things. You can maybe see at the top it's pinching off into droplets, and those droplets fall, and at the bottom some of them are splitting in half and some of them are coalescing together. Some of them survive at the bottom as droplets that sit around for a while before merging together. So when I watched this running, there's lots of questions about what's going on and why is it behaving like this. It doesn't work that well as an hourglass though, because it seems to take a different amount of time each time I run it. I think that's something to do with the conditions up at the top, where somehow the clear fluid has to get back into the top to replace the coloured fluid. But I can watch this for ages.